Welcome to video 1.5, combinations of functions. Don't forget to put your name at the top. When f of x equals 2x minus 3 and g of x equals x squared minus 1, you can actually form the sum, difference, product, and quotient of f and g as follows. If it's f of x plus g of x, that's the same thing as just adding the two functions together and just combining like terms. X squared plus 2x, and then we'd have 3 plus negative 1 is 2. So that's the same thing as f plus g of x. Our rule says that we can do that. The next thing that we're going to do is we are going to, oh, sorry guys, there was a subtraction sign there. Negative 3 minus 1 would be negative 4. Copied the problem wrong. Note to self, kids, make sure you copy the problem right. All right, f of x minus g of x. F of x is 2x minus 3 minus g of x is x squared minus 1. Remembered my negative signs that time. So negative x squared plus 2x. Then we have negative 3. This is a minus minus 1. Negative 3 minus minus, that makes a plus. So negative 3 plus 1 would be negative 2. And that's f minus g of x. So if we're combining these, we can just do it all in one step there. F of x times g of x, so it'd be 2x minus 3 times x squared minus 1. We can distribute, we can FOIL. So we would have 2x cubed first, outside, minus 2x, inside, minus 3x squared, and last, negative 3 minus 1. Combine like terms, there are none, but we could put them in order here. Right there, just in order. Perfect. Okay, last one, f of x divided by g of x. We would literally just do 2x minus 3 divided by x squared minus 1. So we would have that domain that x could not equal plus or minus 1 because that would make the denominator equal 0. So all of these are our sum, product, different, and quotient rules. So in this case here, we would have f of g of x. Like we could divide before we're doing those x values there. Okay, so this next one, it gives us a very similar thing. It just wants us to, it gave us f, it gave us g, it wants us to find f plus g of x. So we do 2x plus 1 plus x squared plus 2x minus 1, combine like terms, and put them in order. X squared plus 2x is 4x. 1 minus 1 is 0. So this is f plus g of x, but it wants it where x equals 2. So now we just plug in 2. 2 squared plus 4 times 2 gives us 4 plus 8. So we get 12. And there's our answer there. Okay, next one says that if we have, this one's very similar, but it wants f of g of x, evaluate the product when x equals 4. I actually want to leave this one for you to do and see if you can figure out that one. See if you can do the multiplication of the two and then evaluate where the product is x equals 4. So you're going to answer that question on the video. So for everyone else, we're going to jump down. Once you're done with that, I want you to try the quotient of two functions. So f of over g of x. So square root of x over the square root of 4 minus x squared. And it wants us to find the domain of f over g of x. So the domain of the top is just from 0 to infinity. We can equal 0, but everything above it because of the square root. But the bottom can't equal 0 because it's in the denominator. But it also has to be greater than 0 because it's under the radical. So we just need to solve here. 4 minus x squared. What makes that 0? Because this has to be greater than 0. It can't even equal 0 because it's in the denominator. So negative x squared greater than negative 4. Divide by the negative. Don't forget to flip your sign. X squared has to be less than 4. And so for this denominator, we're seeing that we can go from negative infinity all the way to 4. So now we just need to figure out where these are going to, or I'm sorry, how did we forgot to square root it. X is less than plus or minus 2. So we have that x is between negative 2 to 2. Negative 2 to 2. Whoops. Okay, it's okay to make mistakes as you go. When we get into the complex stuff, it gets a little bit easier to make more and more mistakes as we go. That doesn't mean that you're dumb. It just means that we need to be a little bit more careful. So we have these two domains. So now we're looking at where are these going to overlap. The smallest that we can go on the top is 0. But that's still within this domain. And this could go to infinity, but we also know that the biggest that we can go to is 2. So our combined domain has to involve both of them. It has to be that overlap of where both of them are okay to exist. So this picture here, it gives you a nice little image of composite functions. Sorry, I was about to say composition. This is called a composite function when you have a composition of functions. Kind of a tongue twister. So f of g of x is a composite function because it's combining them into it. So the domain of f of g is the set where of the domain of g of x is in the domain of f. So you're putting it inside like this picture is showing. So we're going to do an example now. We're going to find f of g of x for f of x and g of x. And then we're going to see if it's possible to find some of these other steps. So f of g of x, that tells us that we're starting with g of x. And we're taking it and we're plugging it into f of x. So what's right here? We're taking and we're plugging into f of x. So we go square root of x minus 1. We're plugging this in for the x on the f of x functions. We work inside out. And we have this value here. So we have the square root of x minus 1. And we know that for this to be true, x has to be greater than or equal to 1 for this to work, because otherwise it will make it 0, or it'll make it less than 0. 0 is okay, but not less than 0. So in this case, we could do f of g of 2, right? Because that is greater than or equal to 1. So let's plug that in. Square root of 2 minus 1 is the square root of 1, which is 1. Can we do f of g of 0? Is that within our domain? It is not. So f of g of 0 is not defined. So that can't be one of our answers. All right, next. Given f of x equals x plus 2 and g of x equals 4 minus x squared, evaluate f of g of x and g of f of x when x equals 0 and 1. So these ones are flipped around. So f of g of x, and do note that they have different notation. That's okay. If you see the little o or the parentheses, they mean the same thing. We're taking g of x and we're plugging it in to f of x. We go inside out. So we're taking where f of x is, x plus 2, and we're plugging g of x inside of it. So that's f of g of x. We could simplify it as negative x squared, and 4 plus 2 is 6. So there's our f of g of x. And then we have g of f of x is going to be, we're taking f of x and we're plugging it into g. So let's look at g and put parentheses where x goes, and we're going to plug f inside of there. F is on the inside there. So let's simplify this. G of f of x, 4 minus, we could FOIL this guy, x squared plus 4x plus 4, and then we can distribute our negative and combine like terms. 4 minus x squared minus 4x minus 4. 4 minus 4 cancels out, so we just have negative x squared minus 4x. And it wants to evaluate them at x equals 0 and at x equals 1. So let's see, f of g of 0 would just be 6, because if we plug in 0 here, that goes away. We just have 6. F of g of 1 would be negative 1 squared, which would be negative 1 plus 6, which would be 5. So we have 6, we have 5 here, and then on this next side, let's do it for g of f of x. So we get g of f of 0 would be 0. Negative 0 minus 0. G of f of 1 would be negative 1 minus 4, which is negative 5. We did it. We did it. We did it. Yay. Okay, next. We are going to find the domain of f of g for the functions f of x and g of x. So we're just looking to find the domain of f of g, but to do that, we have to first, we could do the fog. Let's do the composition of it. Let's do the fog. Plug the g into the f. Square root of 9 minus x squared minus 9. The squared and the square root would cancel off, so we would have 9 minus x squared minus 9. 9 minus 9 is 0, so I would just get negative x squared. Hey, it looks like the domain would be all real numbers, right? Because we have this really simple equation here, just negative x squared. However, this isn't the case. We need to look at the domain of f and the domain of g because they're sending each other to these different equations. So when it asks for the domain of f of g of x or anything like that, you don't actually have to do the composition of functions there because we have to look at the domain of each of this. This one's all real numbers because it's just a normal function. However, this one is restricted because we have the variable, or we have under an index that's even for a radicand. So for this, we know that x has to be, or x cannot be equal, under here, this 9 minus x squared, let's just write it out, has to be greater than or equal to 0, right? It can't be other than that because otherwise it won't have a square root of it. So we subtract 9. Negative x squared is greater than or equal to negative 9. We divide by the negative, which in turn has us flip our radical, and we take the square root. X is less than or equal to plus or minus 3. So that means that our domain has to stay within negative 3 and 3. Okay, write the following. We have this function and it wants us to write it as a composition of two functions. It wants us to come up with our own functions. Well, I can see that in my function here, I have x minus 2 as one of them. So you could do this multiple ways, but the way that I'm going to do it is I'm going to write x minus 2 as one of my single functions, as g of x. And I'm going to write f of x as what would be missing there, 1 over x squared. So, to make this a composition of functions, this would be f of g of x. Why is this? Because I'm plugging g of x in for f of x, which would be 1 over, I'm plugging that in for x minus 2 squared, which equals h of x. That's what I wanted. Perfect. There's multiple ways that you could have done that. You could have set it up differently and still gotten the same thing. All right, who's going to be scared of the word problem? Not me today. I hope not you. We can do it. The number of N bacteria in a refrigerated petri dish is given by N of T equals 20 T squared minus 80 T plus 500, where T is between 2 and 14, where T is the temperature of the petri dish. When the petri dish is removed from the refrigeration, the temperature of the petri dish, this word problem likes the word petri dish, is given by T of T such that 4T plus 2, where T is between 0 and 3. And it says T is the time in hours. So find the composition N of T and interpret its meaning and context. Okay, so we can totally find N of T. We are rock stars at this. We're just taking T of T and we're plugging it in for N of T. So we have 20, and instead of T, we're plugging in T of T. There's a lot of T's in this problem. For every T in N, we're plugging in this equation, 4T plus 2. Okay, so we did the first part there, and now we can go ahead and simplify this. We can go ahead and FOIL that. 16 T squared. I'm going to try to write my T's curvy so that you can keep up there and not confuse it with a plus sign. 16T plus 4 minus, I'm going to distribute here, 320T minus 160 plus 500. So now I'm going to have some more distribution here going on. You can use a calculator, no shame if you need to do that. 320 t squared plus 320 t plus 80 minus 320 t. Isn't that convenient? Some of these are just going to wipe right off. I love it when that happens. So we have 320t minus 320t. So those just cancel each other out there. And now I have 320 t squared. I can combine like terms here. And I'm going to get plus 420. So this is n of t of t. And it wants us to interpret this like with meaning. Like, what does this equation even mean? So this would represent the number of bacteria as a function of time that the Petri dish has been out for refrigeration. How do we know that? Because we're taking the number that are in the dish and we're writing it as a function of time. We're plugging that time into it. So this refers to the number of bacteria as a function of the amount of time the dish has been out or has been unrefrigerated. That's part A. Yay. That wasn't like too bad. We're just doing composition of function. So now it says, find the number of bacteria in the Petri dish when t equals 2 hours. So is that looking for the bacteria as a function of time? No. For where it's at time, we're literally just plugging it in to the function that tells us the number of bacteria, because it says find the number of bacteria. Find the number of bacteria. So we're just plugging this into n of t. So this one, it's just reading the question and trying to figure out which formula does it want me to plug this into. So it says when t equals 2 hours. So I plug in 2. And I'm going to get 400. I could plug all of this into the calculator and I would get 1,700 bacteria. Finally, for part C, we see here it says find the time when the bacteria count reaches 2,000. So we're looking for something that tells us what the bacteria count is. So that means that's going to be n again, because n represents our bacteria count. So we're looking at when is n going to be 2,000. And so that's where we're going to have to work a little bit backwards. So we're going to have to use our formula of 320 t squared plus 420 right over here, because this is the bacteria count, right? We're setting it equal to that n of t, because it's asking for the bacteria count, not the number of bacteria. And so once we set this up, now it's just some simple algebra to go ahead and solve. We subtract 420, and we get t squared equals 1580. 320 t squared equals 1580. We divide by 320, and we get t squared equals 79 over 16, if we simplify that, and we take our square root. So if we do that into our calculator, we get approximately 2.22 hours. All right, thanks for watching.